Today, we are diving into one of the biggest, most exciting breakthroughs in artificial intelligence, self-supervised learning. It's a concept that is totally changing the game for how machines learn, and it all kicks off with one really fascinating question. How in the world can a machine learn about, well, the world, without a human teacher looking over its shoulder? I know, it sounds a little like science fiction, right? But it's the reality that is powering the AI revolution as we speak.
So to really get why this is such a huge deal, we first have to talk about the massive hurdle it helps us clear, what we call the AI labeling problem.
Okay, so here's the problem that traditional AI has always been stuck with. For it to learn anything, it needs data that's been painstakingly labeled by people. Just try to imagine that, the enormous task of paying someone to sift through millions of photos, tagging every single cat, dog, and car. It's an endless, incredibly expensive, and oh-so-slow bottleneck.
And just how big is this problem? Get this. A jaw-dropping 99% of all the data in the world is unlabeled. It's just raw, unstructured stuff, videos, text, sounds. That's a whole universe of knowledge that traditional AI just couldn't get its hands on. Well, until now. So how do we finally unlock all that amazing, untapped data? Well, that brings us to this really elegant solution. Just let the AI learn without a human teacher. This is the self-supervised breakthrough.
So what exactly is self-supervised learning, or SSL for short? Well, it's a method where the AI model learns directly from raw, messy data. It cleverly figures out patterns and relationships all on its own to create its own lessons, its own supervisory signals, without needing us to hand-feed it any labels. Essentially, the data becomes its own teacher.
And what's so cool is that this approach is actually a lot closer to how we humans learn. I mean, think about it. A little kid doesn't need to see a million flashcards labeled cat to know what a cat is. They learn by just observing. They see cats in different places, from different angles, and their brain just figures out the core catness for itself.
And this comparison really lays it all out. On one side, you've got supervised learning, which is completely dependent on humans writing all the labels. But on the other side, you have self-supervised learning, which just dives headfirst into the raw data and finds the patterns on its own. It learns what a cat is simply by looking at millions of unlabeled cat photos. Okay, so how does it actually do that? Let's get into the mechanics. The absolute best way to think about it is as the self-taught method, or basically, learning by solving a bunch of puzzles.
It's this really clever two-step process. First, the AI gets what we call a pretext task. You can think of it like a warm-up puzzle. For instance, the model might get an image with a big chunk missing, and its only job is to figure out what goes in that blank space. Now, by solving millions of these puzzles, it's not just guessing, it's learning really basic things about the world, like shapes, shadows, and textures. Then comes step 2, where all that foundational knowledge it built up gets applied to a real complex task, like identifying objects in totally new images.
All right, let's dig a little deeper, because, it's not all one size fits all. Inside SSL, there are a couple of main learning styles. Let's call them the two main flavors of how these models teach themselves.
So the two main approaches are contrastive and non-contrastive. Contrastive learning, it works by comparison. It's shown a photo of a dog, another photo of the same dog, that's a positive example, and then a photo of a cat, a negative example. Its entire goal is to learn to pull the two dog images closer together in its understanding and push that cat image way apart. Now, non-contrastive learning is different. It only learns from positive examples. So it might look at two different cropped views of the same dog, and its job is simply to realize that these two views represent the same core thing. It's kind of like an artist studying a sculpture from every single angle to understand its true form.
Now, I know this might all sound a bit theoretical, but I guarantee you're using this exact technology every single day, probably without even realizing it. Let's look at SSL in your daily life. Have you ever wondered how Google search just gets you? Even when you type in a messy, half-formed thought? Yep, that's SSL doing its thing. It's the engine humming behind Google's powerful BERT model, which basically taught itself to understand language by playing fill-in-the-blank with billions of sentences. That's what lets it grasp the real context and nuance of your search, not just a few keywords.
And it's the same deal with speech recognition. Anytime you talk to a voice assistant, you're tapping into this technology. For example, Facebook's incredible Wave-to-Vec algorithm learned the basic patterns of human speech just by listening to tons and tons of unlabeled audio. That's what lets it hit such amazing accuracy when it transcribes what you say. And of course, there's the big one, the large language models that have completely taken the world by storm. SL is the absolute bedrock from models like OpenAI's GPT-3. By training on a huge chunk of the internet and learning to do something as simple as predicting the next word in a sentence, it builds this incredibly deep understanding of grammar, facts, and even how to reason. And that's what lets it translate languages, write code, and answer your most complex questions.
So, where's all this headed? Let's wrap things up by looking at the future of AI learning and why this is, without a doubt, a massive game changer.
Here's the bottom line, the ultimate takeaway. Self-supervised learning completely shatters the chains of that old labeling bottleneck. It unleashes AI on that enormous 99% of unlabeled data, which is just dramatically accelerating its ability to learn about and operate in our very complex world.
And that leaves us with one final huge question to chew on. If AI can now teach itself using all of the world's raw, unfiltered data, what in the world is it going to learn next?